Hi everyone, Mr. Lee here. In this video, I'm just going to do some power rule derivative problems. This is just there so that you can see the wide array of different problems that you might see when you're doing the power rule, and just so that you can have this for your record, just in case you're not too familiar / comfy with the power rule. Let's begin. Alright, so the first one, we got y sub x is equal to 5. The power rule, if we do that for here, remember this is just the constant rule, so y prime of x is equal to 0. Alright, number 2, if we have f of x is equal to 5x to the 18, okay, if we take the derivative of this, so we get f prime of x is equal to, so 18 times 5, so I will actually write this out for you initially so that we can see all of the steps. 18 minus 1, so we get 18 times 5, what is that, 90? Yeah, 90x to the 17 as my final answer. Alright, so another one, we're zooming through this. By the way, I'm showing you the different ways of writing out the derivatives. From here on out, I'm going to write it in the way that you will see it here in physics. So we have x of t is equal to 4x to the 5th. Oops, excuse me. That should be 4. X of t is 4t to the 5th plus t. Okay, so we have dx dt. Now, like I said in previous video, this is the method that I like. So 5 times 4, so I will write it out. 5t, 5 minus 1 plus 1 times t, 1 minus 1. After a while, I won't write out all those steps, but I'm just doing it that way so that we can see it. dx dt is equal to 4 times 5, which is 20. T, 5 minus 1 is 4. 1 times t, but t to the, so that's 1 times t to the 0. Whenever we have t to the 0, this just turns into 1. So our final derivative is 20t to the 4th plus 1. Alright, so this is our final derivative right there. Alright, so another one. Okay, so let's do one that's a little bit longer. So let's do let's do x of t is equal to 4t to the 4th minus 5t minus 3. So the first derivative, we got dx dt. Okay, from here now, I'm going to just use a shortcut. 4 times 4 gives us 16t. 4 minus 1 is 3. Minus 5 times 1 just gives us 5t. This is a constant rule, so that's 0. So this is the first derivative. If I wanted to take the second derivative, okay, we will get d squared x over dt squared is equal to 16 times 3, what is that, 48? 32? Yeah, 48. T, 3 minus 1, which is 2, minus 5, that's, yeah, just t, or just 5. Okay, so this is the second derivative. Now if I wanted to do the third derivative, oh man, we're having fun, aren't we? d to the third power x dt cubed is equal to 48 times 2, what is that, 96? Yeah, 96t. By the way, in physics, and we'll get to this later, but the first derivative of a, so this is what we call a position graph. The first derivative is what we call velocity. Okay, the second derivative, this is called acceleration, and the third derivative, this is called jerk. It's pretty cool, and it continues on from there. But yeah, so just cool random facts with Mr. Lee. Okay, let's do one with negative, shall we? Yeah, let's do v sub t is equal to negative 4t to the negative 5th. Now I want to write out the steps for you. So we have dv dt. Okay, so we have negative 4, okay, times negative 5, because we got to bring that negative down, t minus 5 minus 1. Okay, so we get negative 4 times negative 5 gives us 20. T minus 5 minus 1 gives us negative 6. Okay, so the first derivative gives us this. Okay, and just in case you want to see that again, let's try the second derivative. So d squared v all divided by dt squared. So we get 20 times negative 6 t minus 6 minus 1. So 20 times negative 6 is negative 120. t minus 7, t to the negative 7. So this is the second derivative. All right. Now, I do have to tell you that whenever there's negative exponents, I like to do the steps a little bit slower. It just helps my mind to make sure that I know I'm not messing up. Okay. All right. Let's do another one. Let's do x of t is equal to 3x to the third. Wowie wowie. Now sometimes you'll see stuff like this where the exponent is in the denominator, but I am here to tell you that my biggest tip for this is to make it so that you don't have the exponent in the denominator. So this would be just 3, okay, because that's the numerator. And in order to get this x to the third out of the denominator, we just make that to the third to the negative third. All right. So whenever you have an exponent that is negative, that's describing the variable. Okay. So in this case, the variable was that should be t, not x. That variable, which in this case is t, should be in the denominator. Okay. So these two are the same thing. And then from there, I find it a little bit easier because we can do 3 times negative 3. So it gives us negative 9, x minus 3 minus 1, which is 4. So this is our first derivative. So dx dt. Okay. Now, if we were to write this out, right, if we were to put it in a form so that we don't have any negative exponents, this is the same as saying negative 9x to the fourth. Okay. So this is all the same, and this is all the same. Okay. We're saying the same thing. All right. Let's try another one just like that. All right. I'm just gonna make this one up. Let's do a sub t is equal to 5 halves, t to the, I don't know, let's say negative 5. Oh, shoot. It shouldn't be negative 5, it should just be regular 5. T to the 5th. All right. So if I were to rewrite this, I would write the constant, which is out in the front, 5 halves, t to the negative 5th. Okay, so this is saying the same thing. All I did is I brought out the constant, which in this case was the 5 halves. Remember, constants are anything that is not a variable. Okay, so stuff like numbers or maybe even like pi, like those are all constants. Just bring it out to the front, and I have the actual variable, which is in this case t, and then the power. All right. So from here we get 5 halves times negative 2. So I'm going to write this one out just so you can see what goes on here. T minus 5 minus 1. 5 halves times negative 5. This gives us negative 25 halves t to the negative 6. So this will be our first derivative. Okay. All right. Let's do another one. Now you won't necessarily see this as often. And what I mean by this as often is you won't necessarily see exponents that are fraction, but just in case, okay, the steps are the same. So f prime of x, you just bring it up to the front, 2/3 x, 2/3 minus 1. Okay, so we have 2/3 x. So watch what I do here. 2/3. Okay, I don't like subtracting a fraction from a whole number, so I'm gonna turn this into a whole number, minus 3/3. Okay, so once you get the hang of this, you won't have to do this step, but because this is an intro video, I like doing this. All right, 2/3 minus 3, 2 minus 3 gives us negative 1, okay, divided by 3, which is in the denominator, and then we get 2, 3x to the third, like so. All right, so this is our first derivative. Okay, moving on. What if you see something like this? F of x is equal to negative 2 times the root of x. Okay, so if you see something like this, my suggestion to you is to simplify it. I don't know if simplify is a word, but rewrite it, because we know x to the, or the square root of x is the same as saying x to the 1/2. Okay, and there you can derive it, right? So we get f prime of x. Okay, we get negative 2 times 1/2 x to the 1/2 minus 1. Okay, so we get negative 2 times 1/2. This just gives us negative 1 x. I'm going to rewrite this. Instead of having 1, I'm going to say it's 2/2. Okay, once you get used to it, you don't have to do that step, but I like to be careful. 1/2 minus, or 1 minus 2 gives us negative 1 divided by the denominator, which is 2. Okay, so we get negative 1 x to the negative 1/2, aka negative 1 divided by x to the 1/2, aka negative 1 divided by root x. Okay, so this is all saying the same thing. Well, technically, we could, yeah, all say the same thing. All right, so another one. So let's do x of t is equal to negative 2 root 4 t. Okay, so step 1 is to simplify this. Like, I don't like that square root, and so I'm gonna get rid of it, right? Now, whenever we have a number, okay, in that little nook of the square root, you should know that this square root just means that we have a division. Okay, so if there's no number in here, the little spot right there, that means that we have a 1 in the numerator, but that number that's in that little nook is the number in the denominator. So we can rewrite this as negative 2, okay, t to the 1/4. And it's 1 divided by 4 because there's that 4 right there, and that goes in the denominator, and there's no exponent here, so we just leave that as 1. All right, so if I were to actually derive this, we get negative 2 times a quarter, okay, times t to the 1/4 minus 1. And if I were to clean this up a bit, negative 2 times 1/4 gives us negative 1/2. T 1/4 minus 1 gives us negative 3/4. So we could write it like this. You can keep it like that, but you know, if you want to clean it up a little bit, we can say that this is negative 1 divided by 2, 3 to the 3/4. Okay, we can clean it up just like this. And yeah, personally, between you and me, I like leaving it like this, but just in case our math denotes that we cancel stuff out, this is 100% hey okay. All right, wonderful. Yeah, so that's that. Just a couple of examples of us deriving. I think I went through most of it without going to logarithmic stuff and some trick stuff, and when the time comes, we'll go over that as well. All right, bye-bye.